How are you? How are you, Alia?
I'm fine, sir. Alhamdulillah. How are you?
I'm good. I'm good. Let's wait for others, right? And in 2 minutes, it is going to be start time here. So I'll be going to have my after and then I'll be back, right? But yeah, so let me just tell you what we do in today's class, right? So we just continue from where we stopped in the last class, and we were talking about laws of motion, right? And then we were talking about. So first thing that we talked about was this force was mv, right? So this was the second law, and then we also know the conservation of momentum. So this thing we also know, right? And then we also know the conservation of energy, and then because the actual form of this second law is this thing, right? So this is the actual form where this P is change in momentum, right? So, and you see that if F is momentum is what? Mass into velocity, right? So if we write it separately, so this becomes M is taken outside and then dV by dt, and then V is taken outside and then dm by dt. But if we have, right, if we have a constant mass, for constant mass, this term becomes zero, and change of velocity with respect to time, this becomes mv, right? So that is why we get this thing, right? So this is the force. But if we have rocket propulsion system, right? So in rocket propulsion system, we have the mass of the rocket is decreased because fuel is burning, and the mass of that thing is decreased. So in that case, we don't have this term zero, but the rocket moves with a certain speed. So then the acceleration of that thing is zero, right? So then the upthrust of the rocket, this is called the thrust, and this is defined as V dm by dt, right? And mass is decreasing, so this is minus. So this thing is right. So yeah, you have to just remember these things, and then we will apply all these things. So this is the things that we have studied in laws of motion. So we'll apply these things, and then we'll do all these questions, right? So this is based on conservation of momentum. Then this is based on rocket propulsion system. This is FMA, and all these things, right? So yeah, this is the resultant of so we'll talk about these questions, right? The first question we have done in the last class. So we use the conservation of momentum to do this first question, right? And we will continue from here, right? So 8 and all these questions in today's class, right? So where are the rest of? So yeah, I'll be back in a moment, and let me just write the message in here. So okay, so I'll be back in a few minutes, right? And in the meanwhile, you just look at this questions. This is the question. So this is the question that we are going to do, the eighth one. And I'll be back in a Okay, so I'm yes. Can you hear me? Alia, can you hear?
Yes, ma'am. Yes, sir.
Okay, so let us now we know the concepts, right? So let us do all these questions. Yeah, so most of the question would be using the conservation of. So and before we do this question, let me ask you this thing because these the thing you will be using again and again. So and that thing is resolution of vector. So let's say if I have this vector, right? This is my x and y axis, and I have this vector which is let's say 3, whose magnitude is 3, and this angle is theta. So what would be this part? How much would be this part? Yes, how much would be this part? This is related with resolution of vectors. So how much would be this part? Yes, Alia. So this is very important. Yes, hello, Iram. Assalamu alaikum. Can you hear me? Yes, uh, yes, hello.
Sir, you're not audible properly.
Yeah, yeah, yeah. Okay, yeah. So you joined late, right? Just so yeah, we were starting and Alia got disconnected, and then yeah, I was just waiting, and then yeah. So we have just let's start. Yeah. So what we have studied as we have studied the fourth second of motion, that is the change of momentum, rate
Sir,
of
your
change
voice
of
is not
momentum.
audible.
My voice is not audible.
It's cracking. Hello?
Yes, how is it now? What about
No,
now?
sir, I cannot hear you properly.
Let me see what I can just change this. Okay, so what about now? How is it now? Same.
Sir, no, I can't understand you, sir.
Oh, you cannot understand me. So maybe what like?
It's my side. Let me just recheck. Second.
Yeah, yeah, yeah. Yeah, let me yeah, just stop this thing. How is it now? Oh, yeah, this is not what happened.
Sir, your network I think is not stable because I can't. Your video gets stuck.
Okay, so yeah, so how is it now? How is it now?
Yes, sir, it's better.
Yes, can you hear me properly now? Yes, Iram, can you hear me properly now? Yes, hello, Iram, can you hear me properly? No, okay, you're not able to hear me. So, yeah, let me change this. Now, what about now? Can you hear me properly? Yes. Am I audible?
Yes, sir.
Yeah. Am I audible clearly to you? Am I audible?
Yes, sir.
Good. So now let's start. So yeah, today was lots of glitches, right? Just start. And yeah, we were let's do this question. So let's start with this question. I hope that this is what you problem. So let's start with this question. The eighth question, right? This question. And in this question, they want us to calculate tell you about the background of this question, right? And the idea that we have to use is the conservation of. So this is the idea that we have to use conservation, right? Whenever we have these explosion type of questions, this is the idea that we have to use. So an explosion breaks a rock into three parts in a horizontal plane. Two of them go off at right angles. So let's say this is the plane. This is the horizontal plane. This was the rock, right? And then it broke in three parts. So one is going, two of them are going at right angles. So from let's take the easier guess, right? So let's try. So Alia is trying. Yes, hello Alia. So you got disconnected and yeah. So let's say that these are the two fragments. These are the two fragments, right? One is going in this direction, the other one is going in this direction. This is the parent, or let's say this one is the initial stage, right? And these are the broken fragments. So one is going in the x direction, the other one is going y direction. And the first part is 1 kg. So let's say this is 1 kg. And this one, the second part is 2 kg. This one is moving with 12 meter per second. This one is moving with, the first part is moving with 12 meter per second. Second part is with 8 meter per second. And if the third part flies off with 4 meter per second speed, so let's say the third one is moving in this direction, and we don't know the direction or the other aspects of this vector. So let's say this is moving with 4 meter per second, and we don't know the mass of this thing, right? So if the third part flies with, then its mass is, so let's say its mass is m, right? So what do we know? Initially, the explosion, when the explosion broke out, so we have to apply the conservation, right? So initially, what was the momentum? Can you guys tell me? What was the momentum initially? So from conservation of momentum, what do we from conservation of momentum? What is that? Yeah. So from the conservation of momentum, we know that P initial vector. Okay. Your network is unstable. Can't hear you. Oh, okay. What is happening to the network? Can you hear me properly now? Can you hear me properly now?
Yes.
Yeah. So let me change this thing to one, right? Uh, so let me change the current, and then let's do current. Let me change the power. Let me change here the Wi-Fi network. Yes, Anubhai, sorry for this. Right, some internet issues and this is trouble. Okay, sorry about this today's lecture, right? This is troubling. Okay, so yeah, let's just yes, let's start. Maybe this is yeah, just keep it on and then let's okay, so we were doing this question, right? And I told you that the momentum initial, this is equal to final. This is what we have done, right? What would be the initial momentum, guys? Just tell me, what would be the momentum of this mother particle or whatever this thing is? What would be the momentum of this thing before the blast or explosion? What is the momentum of this thing? Is it moving?
0.
Zero. So yes, absolutely correct. So P initial is 0, right? Now for the final momentum, there are three components, right? This is 1, this is 2, and this is 3, right? So let's say that, yeah, let's say that the final momentum will have, right? So this is P final. This would be M1 V1 plus M2 V2 and then plus M3. So this is the final moment, right? And we know that what is the magnitude of all these things, right? So we know that mass M1 is how much? Mass M1 is 1 kg, and then V1 is how much? I got some text. And then V1 is what should be the velocity V1? Can you guys tell me what should be the velocity?
12.
So 12, and what is the direction? This is in the x direction. So let's write it at 12 I hat. And then M, yeah. So and M2 is 2, V2 is 8 J hat, right? And we don't know the, so magnitude of this part we know, right? We'll write that later, but M3 we don't know. Let's write it as M and V3, right? So what is this thing? So V3 would be, and this is minus of 12i minus of 16j, right? And this would be, so if I take this m the other side, so this is minus 12 by m plus minus 16 by m and gm. So this is V3. Oh, right. Okay, learning project. So this would be the V3, right? And all these three are sum up to give 0. So all these three things are 0, right? What we can write? We can write that this thing is 0. So we have this M3, right? And now what do we know? In the given part, what do we know about this thing? What do we know about V3, guys? Yes. What do we know about V3? Let me just zoom out this thing. So what do we know about V3? Can you guys tell me? From here, what do we know about V3? Magnitude is given 4, right? So magnitude we know. So if we calculate V3 magnitude, this would be root of 12 by m whole square plus 16 by m whole square, right? And this magnitude we know that that is 4. So how much would this thing would be? So we can square it both the sides. So this is 144 divided by m square. This is 256 by m square. And then this is 16, right? So we have 144 plus 256, that is 16 m square, right? So what would be 16 m square would be how much? This would be 2, and then this is so this is 0, and then 549, this is 0, and then 2134, so and divided by 60, right? So if we want to find out m, so that would be root of this thing, which is 20 by 4. So this would be 5 kg. Right, is it clear, guys? So we have just used the idea of conservation of momentum. P final is 0 because P initial is 0. We put all these things, we calculate V3, and the magnitude of V3 we know. So that was the idea of this question. Is it clear, guys?
Yes, sir.
Is it?
Yes.
Yeah. So then please note this thing down. Please note this thing down, and then we'll do the next question, right? So let me, this was the question, right? So answer would be B. Just note down this thing, and then we'll do the next question. And sorry about this today's glitches, right? So we'll make up for this thing and some, but just note down this, right? And whenever you guys have noted, just tell me. Whenever you guys have noted, just tell me. Yes. Noted, guys. Noted, guys. Yes, Neelam and Alia. Noted. Can you guys hear me? Did you guys note it down?
Yes, sir.
Okay. Uh, let's do next question. What is happening to this thing? Yeah. So let's to the next question. The next question says that a body under the action of a force. So force is given. Force is given, which is 6I minus 8J and then 10K hat. And acquires an acceleration of 1 meter per second square. This is a very simple question, right? Acceleration is given 1 meter per second square, so we don't know the direction, right? Only the magnitude is given, which is 1 meter per second square. And we have to find out what is the mass of the object, right? So what is the relation? We already know that F is ma, right? So this thing we know the magnitude of this thing is A, and the magnitude of force is what would be the magnitude, right? So F is ma, and magnitude of this force is root of 6 square plus 8 square plus 10 square, right? And then this thing is how much? M and A. And A is 1. So magnitude would be how much? Or mass would be how much? So this would be 36 plus 64 plus 100. So that thing is how much? That is 100 plus 100. So 200. So this is 10. So this would be the answer. And this was a direct question. Is it clear, guys?
Yes, sir.
Then please quickly note this thing down and then we'll talk about the next question. Please note this one down. Whenever you guys have noted, please tell. So today everyone's internet is not working properly. This time Edom got disconnected. Yes, Alia, whenever you have noted, please tell. Please tell me whenever you have.
Noted.
Yeah, good. So now let's do the other question, and that is related with the upthrust force. So the initial mass of a rocket is 1000 kg. Calculate. So mass of the rocket is given, right? In this question, mass of the rocket is given. This is 1000 kg. And what else is given? Calculate at what rate the fuel should be burned. So we have to find out rate of mass burning. Rate of mass burning, that is dm by dt. So this is the thing that we have to find out. What else is given? So that the rocket is given an acceleration of 20 meter per second. So now the rocket is accelerating. So let's say this is the rocket. Right, this rocket is accelerating, and it is actually how much? 20. So acceleration of 20 meter per second. This should be square, right? So accelerating is, and should be 20 meter per second square. So there is a misprint in this question. Right. the gases come out at a relative speed of 500 meter per second. So we know that what is the velocity of the gases, right? This is 500 meter per second. And then T value is given, which is 10 meter per second, right? So then we have to apply the free body diagram in this equation. So what do we know? The acceleration is going upwards, and there is this upthrust force. To move this rocket upward, there is this force which is called the force, right? But this thrust is working against what? Because it is moving upwards. So what is the force that is acting downwards? What is the other force that is acting downwards? Alia, can you tell? Yes. So the force which is acting downwards is always the gravitational force. So gravitational force, that is Fg. Right? What is happening to this thing? Yeah, so this upthrust is this thing. So if we write the free body diagram, what would be the free body diagram? The force upthrust is upwards, acceleration is upwards, gravity is downwards. And what is gravity? Gravity is energy, right? So if we write the Newton's second law, it is called F net, the summation of all the forces that would be equal to mass into acceleration. So if we write the force, what are the forces which are acting? The thrust force and mg. And what is the sign convention? Wally, do you remember the sign convention? What is the sign convention? How do we write the second law of motion from sign convention? How do we write that? Yes. So, right. We write the sign convention as where whatever is in the direction of A, that is positive, that is taken as positive. Whatever is against of A, right? So this is against A. So that would be taken negative. So that is the sign convention, right? I don't know what is happening to this pencil. So behaving weirdly. So what would be positive in this case? What should be taken positive? Can you tell, Alia? Which force is in the direction of thrust? Which force is in the direction of acceleration? Yes. So you see that this thrust force is in the direction of acceleration. So this would be F thrust and then minus because gravity is going against the direction of acceleration, gravity is downwards. So this is against the direction of acceleration. So this would be minus mg. And then we have, mg. Right. So if we write this thing, F thrust is how much? We have already discussed that this is F thrust is simply relative velocity and dm by dt. What is happening to this pen? So this is V relative. This is V relative and then dm by dt. Here something is happening with this pen. Let's see what is happening. So we write the V relative. So V relative and dm by dt. Yeah, you just understand the idea because this is something is happening to this pen. So this is m, and you put all the values, right? So earlier you put all the values, you know the formula. Please put all the values. V relative we know. V relative is 500 meter per second, and mass is given, that is 1000 kg, right? G is all given, 10, and acceleration is also given, which is 20 meter per second. So put all these values and find out dm by dt. Please do that. Please calculate it and tell me. Put all these values because I don't know what is happening to this thing. So put all these values and tell me what is the answer you are getting. Yes, Alia, please put all these values in here and tell me what is the value of dm by dt you are getting. Please put all these values. Yeah, so there is something happening with your internet also, right, Alia? So
Yes, sir,
everybody is
sorry.
yeah, don't worry about. So don't say sorry, right? Don't apologize. And yeah, so because my internet, so we have to find out this dm by dt, and we know every value, right? Oh, I guess now it is working. So what do we know? We know that V relativistic is 500, and then dm by dt, that we don't know. That we have to find out. Minus of, let's take it as equal to, and then this is mg plus ma. So then we can take m common, right? This is 500 dm by dt and then m we can take common, and then this is g plus a, right? So then what's this value? So 500 and dm by dt, and if you put m equals to mass was 1000 kg, and g is 10, a is 20, which was kg. So 500 and then 1000, this would be 2, right? And then this is how much? So this is 2 into 30. So this would be 60 kg per second. So that would be the mass with which the fuel is burned, right? That is the rate with which fuel is burned. So is it clear? This rocket question they usually ask, right? So this one is a very important question. Is it clear? If it is clear, quickly note this thing down, and then I will talk about one more question, right? I will talk about one more question. So just note this thing down. In the meanwhile, let me check this page. What is happening? Yeah, please, you whenever you have noted, please tell. Yeah, whenever you have noted, please tell. Noted. Are you have you
Yes,
noted
sir,
it down?
done.
Okay, so now let's talk about next question, right? The next question is again based on conservation of moment. So we have this. Let me zoom this thing. So we have this rigid ball. So rigid ball of mass m strikes, right? This is the question. So a rigid ball of mass m strikes a rigid ball at 60 degrees. So this is the incoming speed and gets reflected without loss of speed as shown in the figure. The value of impulse imparted by the wall on the ball. So we have to find out the impulse, right? So we have to find out the impulse, and we already know what is that. So we already know that what is impulse, right? What is impulse? So this is a vector quantity, and this is change in momentum, right? Which is P final minus P initial. So this thing we have to find out what is P initial, what is P final, right? So let's say that we have this vector and this is going like this. So this is the vector. And if this angle is, right, this is how much? This is 60 degrees. So what would be this angle? Can you tell me? What would be this angle? What would be this angle? Alternate interior angle. So this would be also 60 degree, right? So we have this vector, and now if we break it in component wise, right? If we break this vector in component wise, so what would be that? Right, let me put it in so if we write it in component wise, this is the component and this is the other component, right? So there are two components. This is x component, this is y component. So you already know that how do we resolve this vector, right? We have to find out mass is m, v is v. So magnitude of this vector is mv, right? This is the initial. So if I write it this vector in ijk form, so what would be that? Can you tell me? What would be that? In ijk form, what would be this vector? We have already discussed the resolution of vectors. Okay, so magnitude is mv, and then we have cos of 60 I hat, and then we have because this is going in minus direction, so minus mv and sine of 60 j hat. So this would be the vector. Is it clear? Is this part clear? Yes. Is this part clear to you?
Yes, sir.
Okay, so this is the initial momentum. This thing we have find out and we'll put the values later. Let's find out. So this is initial case, right? What is the final case? Now we have this vector, right? This is going like this. And this angle is given 60 degrees. So again, this vector, again, mass is same, velocity is same. So this is mv. And it will again have two components, right? This one and this one. Again, this is x and this is y. So what would be that? What would be these components? So P final, this is final case. So P final is how much? This is mv magnitude cos 60. And what would be the direction? The x part. What would be that? That would be minus IF, right? And then we have mv sine of 60. And you see what is the direction? That is again minus j. So this thing is minus mv cos 60 I and minus of mv sine 60 j. So is this part clear? This is the final momentum. Is this part clear? Yes. Is it clear, Alia?
Yes, sir.
So we have to find out the impulse, right? Impulse is how much? That is P final minus P initial. So we just put all these values. So this is minus MV cos 60 I hat minus MV sin 60 J hat minus of this initial, that is minus of MV cos 60 I hat minus of MV sin 60 J hat. So if we write it properly, so what we will have? We will have minus MV cos 60 I hat minus MV sin 60 J hat minus MV cos 60 I hat plus MV sin 60 J hat. So these portions, right, this one will cancel. And what do we have? We have minus 2MV cos 60 I hat. So this is impulse. Right, so what is the magnitude? This is the magnitude. So magnitude of this thing is 2MV cos 60. Cos 60 is half. This is 2MV divided or multiplied by half. So this is M. So this would be the magnitude. MV would be the magnitude of the. Is it clear?
Yes,
Is
sir.
it? Okay, then please note this thing down. So let me zoom out this thing and then please note this thing down. Right. So just note down this one. Start it from here and then just note that and if you have any doubts, please tell. Yeah, so if you have some doubts, please tell me. Otherwise, please note this
Done, sir.
thing. Done. Okay, so now let's do this next question. So we'll do one more question and then we'll stop, right? Because you are here, so I'm not further.